Friends, welcome to my YouTube channel. Dhanesh here. Today we are going to discuss about box plot. This is the sixth video on feature engineering, and in this video I am going to discuss on about box plot, or it's also known as Whisker plot. We will discuss in detail. Let's start. Uh, Before getting into the box plot, I'm just giving some introduction about the feature engineering. The goal of feature engineering is to prepare the proper input data set and improve the performance of machine learning models. So these are all the goals. In feature engineering, we convert data into features. That's very important. These are all the list of techniques used in feature engineering: imputation, handling missing data. This already we covered this area. You can see the video in the playlist. Different methods how we can do, how we can handle missing data. There are different approaches are there. All those approaches we have described in detail. You can watch those videos. Now we are discussing on how we can handle outliers. So that's the thing we are going to discuss now. And the next step is the binding, lock transform, one hot encoding, grouping operations, feature split, scaling, and extracting data. So those aspects we will be discussing in the coming videos. Before getting into that, box plot, see, first I want to tell you what is an outlier. See, in statistics, an outlier is an observation point that is distant from other observations. These extreme values can be present in both dependent and independent variables in the case of supervised learning models. These extreme values need not necessarily impact the model performance or accuracy, but when they do, they are called influential points. All these aspects we discussed in the previous video as well. Extreme values in independent variables are points of high leverage. Extreme values in target variables, we call it as outliers. Very important. See, finding outliers, we have different methods for finding outliers. So we are going to discuss how we can find these outliers. One is, there are two visualization tools we use. One is the box plot and another one is the scatter plot. Mathematical functions we use is z-score and IQR score. Those two are the mathematical functions, and Cook's distance is also another important, aspect to find out the outliers. So in this video I will be discussing about box plot. And what is IQR? We are discussing about IQR as well. So box plot is using this IQR score. So let's find it out. See, box plot is also known as Whisker plot. The easiest way to identify outliers is by visualizing them using plots. If the data is not huge, for example, up to 10K observations and 100 features, it is better to build scatter plots and box plots of the variables. See, here we are going to discuss about box plots, not about scatter plots. So box plots will be covering in this video. This method is not recommended for high dimensional data where the power of visualization fails. See, what are all the characteristics of box plot? It is univariant in nature. It draws a line for the middle value, that we call it as median. See, median, you may be familiar. For example, if we have numbers like 5, 7, 8, 9, 10 and 11, then the median is, we can take the median as, we have numbers like 4, 5, 7, 8, 9, 10, 11. Then the middle value 8 is the median. So first you need to arrange the numbers in the ascending order, then only you can write the median. So this is known as the median. It draws a line for the middle value, that's for median. It draws a box around the 25 percentage and 75 percentage. That I will explain you how we are doing it. It draws whiskers, which will give us an idea about the spread of the data as well. Whiskers, that's why we call it as the whisker plot. So I will explain you, I will show you the diagram. At that time you will understand. The dots outside the whiskers are known as the outliers. Outlier values would be 1.5 times the greater than the spread of the middle data. For that we have the mathematical equation is there. I will tell you how we can find out all this. See, these are all the characteristics. It's a univariate in nature. It draws line for the median. It draws a box around 25 percentage to 75 percentage and draws whiskers out of this 25 percentage to 75 percentage, and again the data coming out of these whiskers we call it as outliers. I will show you that. See, box plot, we need this interquartile range. This is another term in statistics. You see, we call it as quartile. You call it as quartile and interquartile range. So you can watch this is the 6th video in the same playlist. I have a video about quartile and interquartile. That is the 5th video. You can watch it. Anyway, I will be covering little bit the important points I will be covering here as well. So the box plot uses this interquartile range to detect outliers. That's very important. See, what is interquartile range means? The IQR describes the middle 50% of values when ordered from the lowest to highest. To find the interquartile range, first find the median of the lower and upper half of the data. These values are Q1 and Q3. Then Q3 minus Q1 is known as the interquartile range. So you need to I may suggest you can watch the previous video for better understanding, but I am explaining you here as well. I am giving with an example. So this is the value, this is the way we will calculate IQR. Just with this example you can understand it. See, this is the numbers. There are 3 steps we follow to find out the IQR. So this is the given numbers. It is 5, 7, 4, 4, 6, 2, 8. Then we will arrange them in the ascending order. Then you need to arrange in the ascending order to find out the IQR. Then you will get 2, 4, 4, 5, 6, 7, 8. I have arranged in this way. Then Q1, it is the lower quartile, and there are 3 points: Q1, Q2 and Q3. Q2 you understood, it is the median. It is the middle value. Q2 is the median. See, in the quartile, in the interquartile range, to find out the IQR, we need to split the data into 4. That is quartile. Quartile means you need to split the data into 4. Here also you splitted the data into 4. This is 1, this is 2, this is 3, this is 4. So these points, see, these cut points. So see, here 4 is a cut point. This is another cut point. 7 is another cut point. This, to split the data into 4 groups, you need to use 3 cut points. Then only you will get 4 groups. So here the first cut point we call it as the Q1. The next one is Q2 and the next one is Q3. Q2 is the median. So this is from this. After this, after after splitting the data into 4 groups by using the cut points, you will calculate IQR by using the formula Q3 minus Q1. That here IQR is equal to 3 because Q3 is 7 and it is Q1 is 4. 7 minus 4, that is equal to 3. This is the concept of IQR. So I could explain the important concepts of IQR and quartile I explained here, but to understand it in a better way, I suggest to watch the previous video. I will be giving the link in the description as well. It's in the same playlist, feature engineering. This is the sixth video. You can watch the fifth video. It will give you better understanding. Now, the math of box plot. So now you understood what is IQR, what is Q1, what is Q3. So you know this is Q1, 4 is here Q1, 7 is the Q3 here, and IQR is 3. Everything you understood. Now the upper limit here, to draw the box plot, we need a maximum and a minimum. The maximum we call it as the upper limit, and the minimum we call it as the lower limit. Maximum is equal to Q3 plus 1.5 into IQR. IQR means interquartile range. Lower limit, that is minimum, that is equal to Q1 minus 1.5 into IQR, that is interquartile range. Applying below the lower limit and above the, anything below the lower limit and above the upper limit is considered as an outlier. So this is the upper limit, lower limit, and you understood what is Q3, Q1, and anything outside the upper and lower limit, we call it as an outlier. So this is the plot. So this is the box. See, the length of the box will be IQR, interquartile range. See, interquartile range is, it is Q3 minus Q1. See, this is the, this middle value. This is known as the median. It is Q2. Here it would be Q1. This is Q1. And here it would be Q3. So IQR will be, IQR is equal to Q3 minus Q1. So this is the length of the box, that is the IQR, Q3 minus Q1. In our example, we got it as 3. It's 7. So this is the length. See, this distance, this is known as the IQR. Q3 minus Q1, it is that's what. So here, this is the length of the box, and again I have told you the min value and the maximum value that we need to calculate, the minimum value and the maximum value, that is the upper limit and lower limit. So this is the lower limit, the min we call it as the lower limit, max is the upper limit. So how do you calculate the upper limit and lower limit? By using this equation. Upper limit is equal to Q3 plus 1.5 into IQR, interquartile range. Lower limit is equal to Q1 minus 1.5 into IQR, interquartile range. First you need to calculate the interquartile range, that is Q3 minus Q1. Here we discussed. After that you will calculate the Q1 and Q3, that is the min and the maximum value. So these points also, this area, this is known as the whisker, this area. So this is the whisker. So this distance we call it, here also this distance is known as the whisker. That's why we call it as the whisker plot. So anything, so you got this as the minimum value and you got this as the maximum value. Any data point, any data coming outside this min, and there is an outlier here. Here you have outliers. So this is the way the box plot calculate the outliers. Anything coming outside the min and max. See, first we will calculate the IQR, then the min and max. You will use this formula to calculate the min and max, that is Q3 plus 1.5 into IQR, Q1 minus 1.5 into IQR. That also we will consider, and anything again outside the min and max, we will calculate it as the outliers. We will consider it as the outliers. And from this point IQR to max, that is known as the whisker distance. So this is the whisker, this is whisker. So that is the whisker plot or box plot. So that's all about the box plot. This is the sixth video on feature engineering, and it covers statistics and the math behind all these aspects as well. Please like, share and subscribe. Thanks a lot.